Okay, so I just wanted to make a quick video for you guys on what we were talking about yesterday in class involving rational inequalities and polynomial inequalities and setting up a sign chart to solve them. So I'll just do one or two of them really quickly and then let you guys solve some for homework. So suppose we have this. We'll do a nice simple one first. F of x equals x plus 2 over x minus 7. I want to take this, and actually, I suppose we did that in class. So now we want to know where this is greater than or equal to 0. So we said in class, this is no different than regular quadratic inequalities that we did earlier. You have to write it as a rational function. This one already is a rational function, so we're good. Then you have to find all the zeros in the numerator and the denominator. In this case, here I get x equals negative 2. Here I get x equals 7. Those are all zeros in the numerator and the denominator. So now we do a sign chart. And then let's see, we label it off. We have a 0 here at negative 2 and another 0 over here at 7. Now we just pick a value in each interval. It's a sign chart. Pick any value you want in these three intervals and then see what the sign of the function is once you plug it in. So if we pick, say, negative 3, negative 3 plus 2 is negative 1. Negative 3 minus 7 is negative 10, which is 1/10. The value doesn't matter, just that it's positive. Now in here, from negative 2 to 7, I'll just pick 0. If I plug in 0, I get 2 over negative 7. Positive over negative is negative. This interval is negative. Here, from 7 to infinity, I'll plug in 8. 8 plus 2 is 10. 8 minus 7 is 1. 10 over 1 is positive. Now I have my sign chart. Now I just figure out what I want. I want where it's greater than or equal to 0. It's positive here and positive here. So there are my intervals. Negative infinity to negative 2 and 7 to infinity. Now we just have to be careful with parentheses and brackets. The infinities obviously get parentheses. Now check these. I want where it's greater than or equal to 0, so I want to include the places where it's 0. But keep in mind this is a rational function. It's only 0 where it's 0 in the numerator. So at negative 2, I'll get 0, so I want to include that one. So I draw a bracket. Over here, let's see. At 7, that's a 0 in the denominator where it's undefined. Since it's undefined there, I can never include that point, and I draw a parenthesis there. And then there's my answer. This interval union that interval. Again, no different than the sign charts we did earlier in the semester. I'll do one more with a polynomial because it'll give us more zeros to play with. So suppose we have x squared, x minus 2, x plus 3 squared, x minus 7 is greater than or equal to 0. So we're going to do the exact same thing we did before. First, identify the zeros. In this case, that's 0, that's 2, that's negative 3, that's 7. So we do our sign chart again. Let's see, if I label my zeros, I have 1 at 0, 1 at 2, 1 at negative 3, 1 at 7, and then I throw infinity and negative infinity on here. Now do the exact same thing. Again, we don't care about the value, we just care about whether it's positive or negative. So pick an x in each interval, plug it into there and see if it's positive or negative. So here, between negative 3 and negative infinity, I'll go with negative 4. Negative 4 squared is positive. Minus 4 minus 2 is minus 6, that's negative. Minus 4 plus 3 is negative 1 squared, that's positive 1. Minus 4 minus 7 is negative 11, that's negative. If I multiply those out, there's two negatives, they would cancel. That will give me a positive. Between negative 3 and 0, I'll go with negative 1. Again, if I check it out, if I plug in negative 1 squared is 1, that's positive. Minus 1 minus 2 is minus 3, that's negative. Minus 1 plus 3 is 3 minus 1, 2 squared is 4, positive. Minus 1 minus 7 is minus 8, negative. If I then multiply them out, again, I have two negatives, they'll cancel. I'll get a positive. So we're positive here too. Now, I'll just keep erasing this so we can keep doing it that way. Between 0 and 2, I'll go with 1. If you plug in 1, 1 squared is 1, that's positive. 1 minus 2 is negative 1, that's negative. 1 plus 3 is 4, 4 squared is 16, positive. 1 minus 7 is negative 6, that's negative. If I then multiply these out, the two negatives cancel and I get positive. Between 2 and 7, I'll go with 3. 3 squared is 9, that's positive. 3 minus 2 is 1, positive. 3 plus 3 is 6 squared, that's positive. 3 minus 7 is negative 4, that's negative. Here, if I multiply them out, I only have one negative, so this answer will be negative. Pick one more point between 7 and infinity, we'll go with 8. If we check 8, 8 squared is 64, positive. 8 minus 2 is 6, positive. 8 plus 3 is 11. 11 squared is positive. 8 minus 7 is 1, that's positive. All of those are positive, so that's positive. And now we have our solution right here. We want where it's greater than or equal to 0, so we want this, and this, and this, and that. And since we want where it's 0, we're actually going to include these zeros. So as far as this interval goes, I can go from negative infinity all the way to negative 3, but then I include that. All the way to 0, but then I include that. All the way to 2, but then I include that. So I'll go negative infinity to 2. As far as this is 7 to infinity, but I'm including the endpoint, so I'll do 7 to infinity. And there we go. There's my two intervals where it's positive, or greater than or equal to 0. One thing I'll just point out really quickly. Suppose I did the exact same problem, but I only wanted where it was greater than 0. Well then, I have to move all this because we're going to need a lot more room. If I did that then, I couldn't include these zeros, because I only want where it's greater than 0. So I would have to break this up into a whole lot of intervals. And my solution would be negative infinity to negative 3, open. Union, negative 3, open to 0, open. Union, 0, open to 2, open. Union, 7, open to infinity, open. So there is a difference between when you have the strict inequality and when you have the greater than or equal to 0. So just be aware of that when you're solving them. If it's strict, you might end up with something like this, where you have to keep on having open intervals around the zeros. If it's non-strict, then sometimes you end up with intervals that can be combined, like we got when we wrote it the other way. If you have any questions, feel free to email me. I'm going to post an assignment on Blackboard associated with this, along with your homework. And it'll be due on Tuesday like normal.